Okay, these are the 6.2 notes. We're going to look at standard units, areas underneath a standard normal distribution. We're going to look at what we call z-scores. That's the main part of today. So you're going to need your z table, that pink table that I gave you in class. That's going to be definitely useful, or you're going to be very lost. So you want to go through this, try work these through with me, and this will actually become pretty simple if you kind of follow and are able to see how to use the table. So what is a z-score? We want to be able to compare observations from different normal distributions. A simple example of this would be, maybe I want to compare your class that you're in to a different period in dual credit stats. It's a different scenario, different situation. The mean might be different. Standard deviations might be different. So we can compare how you did on like the Chapter 5 test using a z-score. That's the idea. So we're going to kind of standardize your answer or your solution. So the definition of a z-score, I'll just kind of move that down. It's the number of standard deviations between this measurement and the mean. If you think about it, it's the distance from the mean, but not necessarily a raw score. Like if your mean class average was an 80 and you got a 95, it's not 15. Okay? It's not how far you are, it's the number of standard deviations you are. That's the definition of a z-score. So we're going to make comparisons using these different distributions. A z-score can be either positive or negative. Positive obviously means that you're above the mean. Negative means you're going to be below the mean. And z-scores are rarely greater than 3 or less than negative 3. Why? Hopefully you guys are thinking about the empirical rule and that little picture from last night's notes, or the 6.1 notes, because 99.7% of your data is within 3 standard deviations away, right? So if you are above or below 3 standard deviations away, you're in the 0.3% category. That is rare. That'd be a warning sign if we go back to our control chart. So it is rare that you get that. How do I calculate a z-score? It's the number of standard deviations away from the mean. So this is simply how we calculate it. This is in your notes, your formula sheet, excuse me. So you will be able to see this, but you need to know this formula. It's the number, kind of what you get on your test. You subtract the mean in the problem, and then you divide by your standard deviation, and that's going to be what we call our z-score. It's in standard units. It does not have a unit attached to it, so we can compare them. So a simple example. The amount of time it takes for a pizza delivery is approximately normally distributed with a mean of 25 minutes, about 25 minutes to get your pizza. We figured out that the standard deviation is 2 minutes. I want to convert 21 minutes, say it took you 21 minutes, to a z-score. Well, if you think about it, before I even do the formula, okay, I'm 2 minutes standard deviation wise, and 21, notice we can say that's 4 minutes before we expected to get it. Hopefully you guys are thinking, hey, that's 2 standard deviations away to the left. Well, if you do the math, 21 minus 25 is -4, divided by 2 is -2. That means we are 2 standard deviations to the left, okay, or below the mean. And that's what it means, and then we're going to use this table to kind of figure out what that means. We also can reverse it if I want to find a raw score. So maybe I want to find actually how long it took you to get your pizza, or really what you got on a test if we knew your z-score, or if we knew the mean and the standard deviation. So this is also a formula that should be in your formula sheet, and something that we're going to use as well. So we'll kind of look at both sides of this thing. So what happens if I go back to that same problem? Mean is 25, standard deviation is 2. And let's say I know that your z-score, like you got it in 1.6 standard deviations above the mean. How long did it take you to get your pizza? Well, simply stated, it's your z-score times your standard deviation, and then you add your mean when you do the algebra. You just plug it in, and you get your pizza in 28.2 minutes in this case, or about 3.2 minutes above the mean. And that's kind of the idea that you can do. You basically multiply it by your standard deviation, and you add your mean. Okay, what is a z-score in general? It has the same, the empirical rule. If we go back and look at that, 1 standard deviation each way has 68% of our data. 2 standard deviations each way has 95, and then 3 has the 99.7. That's not changing. They just standardize it and say, hey, whatever your mean is, that's the middle. Whatever your standard deviation is, that becomes a z-score of 1. Standard deviation, 2 standard deviations away, and so on. And they just kind of make it. It becomes a normal curve, and that's the idea. So it's any normal distribution can become standard normal, and we just kind of make that happen. So let's go back and let's look and kind of figure out what these probabilities mean. So this is where you need your pink sheet, or if you don't have it, it's on page A22 in your book, and there are 2 different tables. There's what does it say? Table A, and then there's table like 5. I think is kind of the idea behind it, but one of them has positives, one of them has negatives. Okay, so we always round a z-score to 2 decimal places, and I'll show you why that's important when we get there. If you have a z-score less than negative 3.49, if you look at your negative side, that's the shortest or the smallest it can go, we presume 0. And if they get a z-score that's greater than it, we use the 1 for approximation. Now why do we do that? Because everything needs to be going to the left. Okay, so here's how this works. Entries probability, standard normal, and we get a negative sign. So if I look at a normal curve, you are going to be, if it's negative to the left, that's table 5, you'll have negative signs in there, and we're going to be somewhere on this side. And what this means is wherever you're at, however many standard deviations you're at, we are going to get the number or the probability that's to the left. I cannot emphasize that enough. If you have a positive z-value, that means you're going to be somewhere to the right of the mean. Maybe, let's put a different color here. Maybe your z-value's here. It's going to be all of this data to the left is what that number is going to insinuate. All the numbers above the mean will have more than 50% or 0.5. All the numbers to the left of the mean or negative should be smaller than 0.5 because this is symmetrical. Your mean is exactly 50%. So let's kind of talk about this and see if you guys can do this. So I want you to see if you can find the probability if you have a z-score of 1.34. So how does this work? You need to find the positive table, and I've kind of pulled out one part of it. But on the far left side you have a z-score. Think about this as kind of a stem and leaf plot in a way. Here's your stem. The 1 point, whatever the tenths number is, okay, will be here. So we want 1.3. That's what you need to find, that row. And then on the top is your hundredths place. So in this case we're looking for the 4, but it's listed as 0.04. That's wherever those meet. That's the probability for the 1.34 right in there. Okay, so that's 0.0999. So 90.99% of our data is to the left of the z-score of 1.34. So if I draw a normal curve, here's my mean, my inflection point, 1 standard deviation away. So I'm going to be just farther than that 1 standard deviation away. 90.9% of my data is to the left, this direction. And that's what that means. All the data underneath my normal curve should always add up to 100% or 1. Okay? Let's see if you can figure this one out. Find the area to the left of z equals negative 2.67. So you need to go to the negative side. Find negative 2.6 on the left going down, and then the 0.07 on the top. Go down to where those meet, and hopefully you find 0.0038. So that's the idea that you need to do. So 2.6, 0.0038. See if you can find that, and if you can do that, I promise you the rest of this is going to be really easy. So patterns. Now your table always gives to the left. So if I say find the area to the left, it's really easy because it's just the number given in the table. Okay, so whether it's a negative one or a positive one, if it says to the left, really easy. What's trickier is what happens if I say the area between two numbers. Okay, what you want to do is basically take the area. Do not take the z-score and subtract them. Find the area in your table. So the two numbers in table, or the probabilities, and you will subtract them. So basically you'll take the bigger one, or Z2, minus the Z1, and I'll show you an example of that in a second. Okay? And it doesn't matter if one's on each side, doesn't matter if they're both on positive or both on negative. Take the larger one and subtract them. Okay? And that's kind of the idea. That's what you want to do. So if you want something to the right, here's where you got to put yourself in the scenario. Okay, I have something that I want to know, maybe the Z value is 2.67 or whatever, and I want to know the probability I get more than that. Well, the table's going to give you a number that's to the left. Let's arguably say it's 0.88. Maybe 88% of my data is to the left in this problem. Well, what happens if I want to find the area that's to the right of it? Well, your whole curve adds up to 1 or 100%. So basically, we got to think the complement. I go 1 minus 0.88. That means it's going to be 0.12, or 12% would be to the right in this scenario. So you're going to have either left of something, right of something, or between these Z values. And that's what we're going to do the rest of this. So what would be kind of cool is if you could pause this, take a stab at it, see if you can get these answers, and then I'm going to go through it with you. So this first one, Z is less than or equal to 1.24. If you find 1.24, since it's less than it, that's what we're looking for. Now I'm going to draw these out. If you guys get in a habit of this, so I'm to the right, and I need it to the right of the mean, and what I mean, so that means Z is 1.24, and I want the information to the left. Well, it better be more than a half, okay, because that's, half would be the top of it. 0.8925 makes sense to me. Here's the between situation. Well, first of all, you want to go to your table and find out what is the information of Z-score of 1.6. If you go to 1.6, that's 1.9452. And I need to subtract it from whatever 0 is. Well, 0 is your, so this is 1.6. Here's my Z-score of 0, because that is your mean. I only want to find this information. So 1.6, this 94.52, is the information from this line all the way over. Well, I don't want this. So I need to subtract whatever that number is away. Well, hopefully you know, and you shouldn't even have to find it, but the mean, or 0, Z-score, is exactly 50%. It's half of it. So I subtract it away and I get 44.52. And then here, if I want probability of negative 2.37 to 0, I'm now starting at 0, and negative 2.37 is over here. I want to find this information. Well, I'll start at the far right. That 0 is, we just talked about it, 50%. And I'm going to subtract whatever this number is. Well, keep in mind, negative 2.37 from your table is the information to the left. Excuse me, I need to find the pen. And I don't want that information, so I'm going to subtract that away. And I get 49.11 as my final answer. So these would be your final answers for probabilities of those intervals. And then here are 3 more. And I'm going to talk a little bit less. Okay, so 1.88 to 1.24, subtract them, see if you can follow that. What's different? I want a Z-score. What's the probability? That's why I have the P, by the way. I didn't really talk about it on the last page. Probability that your Z-score is greater than or equal to 2.39. So, oh boy, here's your mean. 2.39, Z equals 2.39 is somewhere to the right. And I want the information to the right, so I actually want this information. Well, the problem is your table always is going to give you the information to the left. I don't want that. So I know the entire curve is 1, and I have to subtract whatever the number is that we don't want. Well, this number in your table is 0.9916, so only 0.0084 is the information to the right. Okay, and then the last one is the negative one. I want to the right of this negative 1.43. Same principle. 1 minus whatever that number is from our table. So if I would draw this one again, just quick for you. Here's your mean. A Z-score of negative 1.43 is somewhere to the left over here, and the number you get in your table is going to give you this one. Well, we want that information now. So once again, we can go 1, subtract what we don't want, and that would end up being about 92.36. So that's the idea. A few things to note. It does not matter if it's equal to or greater than or equal to or strictly greater than. It does not matter which one we do. Your calculations are not going to change. Please, please, please do not worry about it. And then one last application. Okay, so going back to the pizza thing. What if I want to find the probability from my table that you get your pizza from 25 to 27? You need to build your z-scores into intervals with this scenario. So what I'm going to need to do is 25. You might want to take your formula. I'm going to try and move this stuff up. Okay, so I'm going to go 25. So 25 minus 25 over 2. The raw score of 25 minus my mean of 25 over 2 is 0. So I know I have what's the probability of 0. My z-score of 27 minutes would be 27 minus 25 over 2. 2 over 2 equals 1. So I'm between 0 and 1 standard deviation away. If you think about the empirical rule, I'm like, ooh, that should be 34% from that picture we had a couple days ago. Well, if you go into your table and find 1.00, that percentage is 0.8413. And then I need to subtract, what's the probability of a z-score of 0? 0.5000. So my A answer is 0.3413. That's using the table, the exact answer, where the empirical rule gives you an approximation of 34. That's really close. So how about less than 30 minutes? So I'd say probability that x is less than or equal to 30 minutes. That becomes, okay, 30 minus 25 over 2. So 30 minus my mean divided by my standard deviation, and I get 2.5. So what I'm looking for on part B here is what's the probability that my z-score is now less than or equal to 2.5. And if you go to your table, okay, it's only less than, so I can take the number that's actually given in the table, and if you find 2.50, it's 0.9938. So that would be my best answer. Less than 22.7. Here you're going to probably have to get a calculator. X less than 22.7. Notice I can go less than or equal to. It does not matter which one. To find my z-score, because that's what you need to use now, I go 22.7 minus 25 divided by 2. And I end up getting negative 2.3 over 2. So z-score of negative 1.15. So if I go back to my original problem, this becomes the probability that my z-score is less than or equal to, or less than, doesn't matter, 1.15. And since it is less than, since I did not change it to have an interval, I need to just find that number. So if you go to your table, negative 1.1 and then 0.05 on top, see where they meet, your best answer is 0.1251. And that's your way of applying this problem using z-scores to find probabilities. And this is what your homework's going to be the whole time. And that's what we're going to work on in class. So hope you all have a wonderful day.